I think is really worth thinking about. I say it's possible to create a brand new power series for a function. What I mean when I say that is that you could go through the Taylor construct where you have a centering point and you do f of 0, f prime of 0 times x, f double prime of 0 times x squared over 2 factor, right? You could go and basically from scratch, you could build a new Taylor polynomial and turn it into a power series by extending the terms forever. You could do that for just about any series as long as it has the right, the derivatives as you keep going, right? But I say here, often it's easier to just take a series that you know, like these four, and just manipulate it using the rules of algebra and the principles that you're all really good at to arrive at this new series. Does that make sense? So, I thought I would do, oh boy, the sugar is coming back to get her, or something, the drink. What I thought we would do here is I'd show you this first one, and then I'd like to get done with at least, 4 of these today, something like that. But I want to mention the ways that we will use, the methods we will use here are algebra, just basic algebra. Basically, the algebra rules would be, if you multiply one side by a certain quantity, as long as you multiply the other side by the same quantity, you've maintained balance, like those sorts of principles. Substitution is another really handy one. Integration, differentiation also. We can even do some combinations of these, right? You might do a substitution and a multiplication or something. So anyways, I think number 1 is a good place to start here. And so here is where, right off the bat, your sense of these 4 memorized series would be super important. This says that we're supposed to write a power series for this function. And my hope is when you see that function, your first thought is like, oh, I've seen something like that. So of the 4 known series, which one looks a lot like that? Not sine or cosine. It's the 1 over 1 minus x. So maybe, I'm just picturing you guys doing a quiz or a test or something and say, oh, it looks like that 1 over 1 minus x thing. And so maybe you'd write this out and you'd say 1 over 1 minus x. Well, this equals 1 plus x squared plus x cubed plus ... plus x to the n. And you'd say, all right, indeed, this does look a lot like this function that I'm supposed to find a power series for. And the truth is I could go and find a bunch of derivatives and do that. But wouldn't it be easier just to take this known series and just make a little tweak to it? So what do you think? What little tweak, what algebra, substitution, integration, differentiation, what little tweak could we make to this to get it to a place where it is that function? What could I do to that left side? So I'm focusing on this. Like, how could I change that so it looks like the other blue box? I'll let you think.
Square it.
Square it.
No. Yeah, square it and then square root it. Get rid of that.
Okay. Look at that menu of 4 things up there. It's one of those 4 things. Algebra, substitution, integration, differentiation.
No. You could do you could multiply it by 1 plus x over 1 plus x. No, you couldn't. Never mind, I'm tripping.
Well, you could do that, but would that get us where we want to go?
No, because I was thinking like we use difference of squares to like simplify.
And then we just end up back where we started, right?
Yeah.
Yeah. Okay.
Could you do it like 1 minus x over 1 plus x?
You mean multiply by that?
Yeah.
Yeah, whatever you multiply the top by, you multiply the bottom by.
Just don't listen to me.
No, all these are good ideas, because so far, we're just throwing some things out there, and so far you've kind of shot your own selves down. And that's good, because none of the ideas so far have been the right idea. Let's keep thinking. You're going to love it when you finally see it. It's very simple. It really is. It's just...
Don't say that to me.
No, did I say easy? Simple does not mean easy, right? Sometimes the simplest things are the hardest things to see.
Plug in negative x for every single x.
Wait.
That's what I was thinking.
Okay, so if I plug in negative x for every single x, focus only on the left side for a moment. Would this get us where we want to go?
Yeah.
Yes.
1 plus x in the bottom, right? So if I did that, then what Jack said is right. I've got to do that to all the x's, right? Otherwise, it's not a valid substitution. It does, and this is it. So I could clean this up just a little bit and say 1 over 1 plus x is equal to 1 minus x plus x squared minus x cubed plus dot 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 plus negative 1 to the n times x to the n. So that is it, right? So it's just a one substitution process here. I cleaned it up a little bit, but you really don't even have to clean it up. But I thought I'd clean it up for you. By the way, listen up, ladies. If you wanted to, we're going to move on here in just a second. But if you were bored and you wanted to prove this to yourself, what you could do is you could take that f of x and you could do a Maclaurin polynomial for it, do f of 0. I mean, check it out. F of 0 would be 1, right? And there you go. There's your first term. And then you could do f prime of 0 times x, and f double prime of 0 times x squared over 2 factorial. And you'd find in the end that it does end up being the exact same thing. But wasn't it easier just to go negative x substituted, bam, 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 done? I hope that you'd see that as being easier. I certainly do. Okay, so that's kind of your first taste. What do you think? So if I was going to pick one of those four, which one was it? Did I do algebra, substitution? It was substitution, yeah. So for number one, we used this, substitution. Okay. Why don't you guys try number two now? Number two says, right, the first four terms and the general term. I guess I didn't do an interval of convergence. Let's do that. We'll come back. We'll maybe just do that once or twice. I think I put them on almost all of them. We'll practice that once or twice, but we won't do it for every single one of them. So do number two, right, the first four terms and the general term for the power series for this new f of x. So consider those four options, because we are going to take a known series and just mess with it. Algebra, substitution, integration.
Can you do substitution again?
I don't know, try it out. So basically, the answer to a question like that will simply be two-part. Does it get me where I want to go? And did I break any rules getting there? Right? So if it got you where you want to go and you look at it and say, hey, everything was logical and mathematically supported, I'd say you did it. So these will be, you'll kind of know. You'll kind of know when you're stuck and kind of know when you got stuck.
What do you mean mathematically supported?
Like, let's say that I multiplied the left side by x and the right side by x squared. Like, that's not mathematically supported, right? You can't do two different things to two different sides of the equation. Or multiply the top by x and the bottom by 3. Well, now change the value. You can't really support that mathematically. It's now something totally different.
I could do so much more if it wasn't the denominator.
Yeah, I'm good.
Just put the negative inside of the x.
No, I'm good.
You can plug anything into x.
But
X
you
can
can't
be
change
lit.
the sign.
Yeah.
Aiden, stop, get out. No,
Well, I would actually make it
no,
one
if 1 over 1 minus x, it'd have to be 1 over 1 minus. And then if you put negative x.
Mr. Anderson,
Yes, sir?
can you help me be creative just a little bit? That's the best question I can ask you.
Can you? So,
Yes, that's what I'm saying.
so first of all, have you picked out the series that you'd like to mess
Not how
with?
math works.
I want to do 1 over 1 minus x.
And that makes sense, right? Because that's the only one that even remotely looks like this, right? Because the other ones are cosine, sine b. That one makes no sense.
plug it.
Okay, so if you're going to start off with that, you go 1 over 1 minus x. What I like to think about is, what's been changed? Has like the whole top been changed? The whole bottom been changed? Or just one little part of the top or one little part of the bottom?
Well, two key parts of the bottom have been changed. It's the sign and the degree.
It's really that second term's sign and just nature of that term have changed. So let's think about it like this. What if it was 1 over 1 minus x squared? What would you do?
I would just plug in x squared. X.
That makes sense.
Yeah.
Because that would get you exactly what you want. So substitution. So can you think of a way to do something similar to that, but would get you to the thing we actually want? Think similarly the way you just said, 'cause I changed that plus to a minus and it took me 2 seconds.
Yeah.
So just extend that one little step further and say, okay, how can I turn the minus that I know is already there into a plus?
Well, I mean, you'd want to multiply it by the negative one, but I don't know how to put it in there because x squared would just make it. Wait, do you just plug in a negative x squared?
Were you thinking that
Oh,
negative x times negative x is positive x squared and that would,
and that you couldn't do that because I'm just thinking you have to plug stuff in just like very much inside the x value. That's the only place you can
no,
really
you
plug
can,
stuff in.
you can substitute a whole term. Like for example, like think back to substitution back in algebra 1, right? So like if you had 3x plus 9y equals 12, and you had y equals 7x plus 4, can't you take this whole thing, however big or simple or complicated it is, and you can put this whole thing in for y?
Yeah, I guess so, yeah.
So yeah, it can be a pretty large thing or complicated thing
Okay.
that goes in there for a substitution.
Okay, because I was thinking of almost plugging in an unsimplified negative x to the third over x,
Uh-huh.
and then it works because then you just plug it in, and then you simplify afterwards, and then it's negative x squared, which makes it a positive.
And that's the definition of overcomplicating it. It sounds like that would work.
Okay.
I
I guess I reached the exact same solution that you just led me to. I just couldn't like
Yeah.
envision. Just
But the
putting
steps were a lot more complicated,
Yeah.
right? Oh, let me write it out for you real quick.
Okay.
I think I see what you're saying, because you were like wanting to plug into the thing that's being squared.
Exactly. Like,
Right.
I wanna, like plug into x itself.
Yeah, I totally get it. Totally get it. It's almost like you were thinking backwards too. You were trying to square something instead of saying, well, it's not squared to begin with, so we don't have to square anything unless we put a squared in there. Okay, so did you guys identify this as the series that we would use again?
Yes.
1 over 1. That's the only thing that even looks like, it's not even close, right? The other one is cosine. The other one is sine. The final one is e to the x. None of those look like this at all except for this geometric series. So once again, I'm going to write this up on the screen. This is for those of you that are a little more visually oriented. I think if you can just see it a bunch of times, it'll help. So then, did you guys arrive at substitution as the right?
Heck yeah.
What did you substitute in?
Negative x squared.
Yeah, if you substitute a negative x squared in for x. So here's what it could look like. 1 minus negative x squared. Okay, so if you plug that in, on the left side, you've got to plug that exact same thing in for all the x's on the right side. So it would be 1 plus negative x squared plus negative x squared squared plus negative x squared cubed, so on and so forth. And then it would be negative x squared to the n. And then finally, you could clean it up a little bit so it officially looks like what it is we're supposed to be doing. So it'd be 1 minus x squared plus x to the 4th minus x to the 6th plus, all the way out there, it'd be negative 1 to the n times x to the 2n. And we'd have our nth term to go along with our first 4 non-zero terms. So again, algebra, substitution, derivative, integral, what did we use? Substitution again. So yeah, substitution is a handy method for these, but we will definitely get to others. But the first two so far have been substitution.
How did you split negative x squared to the end, negative 1 to the end?
So yeah, so this is really negative 1 times x squared to the n. And then that n just applies to both bases. And I personally like that because if I was going to go on to do an interval of convergence for this one, I'd want to just get that negative out of there. And so by splitting that out, you can get to just like the non-alternating part.
If I'm answering this in the test and this is all it's asking, or I guess if it's not asking for the interval of convergence,
Yeah.
can I just leave it as negative x squared to the n?
Yeah, and really, yeah, that's a great question. So if it's a quiz or a test, and you don't have to do anything else with this, then leaving it right here would make the most sense. Yeah. Frequently, though, I can think of some questions for sure from a lot of recent AP tests where maybe part A was something like this, And then part B was, okay, now combine it with this other series in some form or
Yeah.
fashion. So that's where simplifying would make a big difference.
Sure.
So you might have to do that. It's not that difficult, but from a time-saving perspective, yeah, consider. Okay, any other questions? These are all really, really great questions, and make sure we're solid. Okay, cool. So number 3 then. Number 3.
Convergence for that one is the same as the 1 over 1 minus x.
So for the previous one,
Yeah.
yeah, I don't remember about endpoint behavior, but it should be a radius of 1 centered at 0. Say again?
You just redo the endpoints.
Yeah, just retest the endpoints. Yep, exactly. All right, so number 3 says, find the first 4 terms in general term for the power series for this new f of x. Should be interesting. More sugar than a can of Pepsi.
How much sugar is in a can of Pepsi?
According to this, 1 cup has 32 grams of sugar. This is right up the value.
Less sugar than a Red Bull.
Less sugar?
Yeah, 12-ounce Red Bull has 42 grams of sugar.
Okay. Oh, that's close though. It's very
And a
close.
cup, well, actually.
1 cup is less than 12 ounces.
One cup is 8 ounces.
Yeah.
An 8-ounce Red Bull has
Just do it in proportion to wearing that class.
30 grams of sugar. Approximately.
Yeah, is that what you for important soccer match? You down a Red Bull and go out there?
No, never had Red Bull.
I've never had
No, it's in, it's in the money
No,
now.
it's a
Monster's
different-
better.
Recipe for crashing.
Unpopular opinion, Monster.
The only Monster I like is the green one. Yeah.
I don't like it, yeah.
It's
Remember when-
very sweet.
Rebels are fine.
Remember when I asked you for a Mountain Dew and you got me a Monster?
Or would you
At
Um,
church?
No, I wasn't doing it.
You were just so tired.
This
you
is
just
the
grabbed a
weirdest
Monster.
story I've
And then,
ever heard.
and then you started complaining about it, and I was like,
It's just like high.
Well, it was my first Monster, and I started drinking, and I was like,
high
it's like my addiction's to it.
It's like somebody who drinks
love it.
something that they didn't know was spiked.
Makes a difference.
Yeah.
Like, that was really good.
Start peeking now. Alright.
I remember, I don't know, I think it was my cousin. He was like 8, and they were in like the Bahamas, and his grandmother
See it?
was drinking pina coladas.
Is that right?
And he tasted it, and he was like, this is amazing. Pina coladas are delicious.
Well, I'm a pina colada guy.
You don't like pina coladas?
No, okay, that's why you're sitting there.
You substitution?
Oh.
So tell me what you substitute.
You don't like pina colada?
I'm not even kidding. I was like planning on just driving home, like doing that.
You gotta be careful.
It's not bad.
You gotta be careful.
You're not.
That stuff.
I didn't even know. No.
Okay, let's do this one, and we'll do number 4 to finish off. Hey guys, listen up, please. Did you all see this right away? It's got to be some version of that.
Yeah.
Yes, absolutely.
And can you see how number 4 screams, like looking in the future here, number 4 screams something else besides this
Yeah.
geometric? Okay, so I just want to make sure you see that it does get different sometimes, but this is a really common one to use. So again, I'm just going to write this out so that you can see it for like the 6th or 7th time today, like so. By the way, this power series for 1 over 1 minus x, what's the centering point for this power series?
0.
Centered at 0. I agree. Centered at 0. Okay. So then going around, a lot of people said they use substitution.
Yeah.
again for the third time, and that actually I think makes sense here. So what I'm going to do is I'm going to write 1 over 1 minus blank. What do you think would have to go in the blank there for the x to make this work?
1 minus x.
So let's think this out over here. 1 minus x. So if I did that, it would be 1 over, if I distributed, it would be 1 minus 1 plus x, which is indeed what we wanted.
Wow.
Seems to work. How about that? Love the substitution there. And I think that's certainly one good way of doing this for sure. I think we'll go with that. So then whatever I substitute in for x on the left, I've got to substitute again on the right side the same way. So I'd go 1 plus 1 minus x plus 1 minus x squared, so on and so forth, plus 1 minus x to the n. So then, do you notice anything unique about this new power series that we've made that's pretty different from... It's got a different... What's the centering point for this one? That's 1. You'd set the 1 minus x equal to 0 and solve for x.
Oh.
So just like you would do with like a horizontal shift, like on a parabola or something.
I gotcha.
So the centering point is 1.
Or it's like, if x equals 0, what is?
True. Okay, so if the centering point is 1, does anybody have any ideas? If I were to say this statement that the series for this function, I'm putting a blue box around it, the series for this function can't be centered at 0. Ours is centered at 1. And I'm telling you that it can't be centered at 0 for this one.
Because he's not centered here.
It doesn't exist as
So there's no function at 0. So f of 0, f prime of 0, f double prime of 0, all those degrees of derivatives wouldn't exist. So there's no power series there. So if you wanted to do a power series for 1 over x, you've got to center it someplace other than 0. And for us, it was convenient to use a 1. Does that make sense? Okay. Okay. What do you think this would do to the interval of convergence?
shift it right by 1.
Yeah, so the interval of convergence would be 0 to 2, test the endpoints. 0 to 2, test the endpoints. You guys good? Okay. So let's make our final effort here, number 4. Number 4 says, write the first 4 terms and the general term for the power series for cosine root x.
Oh, I did it. This one is so much easier to see.
It is.
Because you just switch the
You can
inputs.
just see, you can see it because it's harder to make this look different. Like with
That's
geometric, it's easier to just like take it and change it
Yeah.
into something hard to see.
Because this one you have a set place where your input's going to go anyway, so it's not.
Yeah. Yep. Well, so again, I just want to reiterate to you guys, what I'm trying to teach you here is that there is an easier way to do some of these, right? You could start off by doing f of 0, f prime of 0, f double prime of 0, f triple prime of 0.
That's cool.
You could do all that, or you could just choose one of these manipulations of the series that you're already supposed to know, therefore making it much easier.
So like for this, it's like of x, you can just plug in through x, call x as
Yep.
This is really not as hard as I thought it was gonna be.
Yeah, I mean, I completely agree. There's just different stages to it, right? Like if you don't know the 4-node power series, this is going to be impossible. Or it's going to take you forever if you have to construct a new series for every one of them. And then once you get to that place, then it's a matter of getting the experience of like, oh, this one is substitution. Obviously all 4 of them today have been substitution, right? Later on it's going to be, oh, well, maybe I should multiply something on both sides, or maybe an integral is the right way to go, right? Yeah, you'll see all those. So I'll let you guys finish it up. I'll just kind of get it started up here. The hope is that you would remember this.
Did you see it?
Yeah.
And then substitution.
Takes a select group of scope.
Cool. Lucky for me.
Are you gonna take Caitlin?
I don't know if I'm gonna do that yet. We have not texted at all.
Plus, it was just really weird, the entire thing was really weird. Well, yeah, dating me.
I know, right? It was, yeah.
Not to, burst any bubbles.
Oh, no, I know. Like, as I was getting her number, I was like, I don't know if I'm all about this.
It's okay.
Ew.
She's a little odd. Yeah, I figured that out.
She's cool, but.
Why would you ever do that to me? I don't even have that. Okay, I don't know what's bothering me.
Plus,
Did you guys get this? Please look what I'm writing.
My eyelashes instead. Dude, I'll connect them.
I totally messed with that.
Ladies, Julia, okay. Did up with what I had?
Uh-huh.
All right. So I want to quote Julia from 2 minutes ago. She said, "Oh, this is not as bad as I thought." Or some version of that.
Yeah.
Just didn't even have to use your calculator.
True,
Guys,
yeah.
when I don't
Are you guys
have
feeling
to think
similarly
about
at this
it.
point? I hope you are. So for Monday, obviously it's going to be Sam, Aiden, and me. I think that's it.
Next to you.
Oh, yeah.
So just so you all know, we are in a really good place, timing-wise, and assuming we don't have like a snow day, God forbid, we are not going to progress on Monday. I am not going to like do 4 or 5 more examples and just make a video. I think we can do this just fine with the other 3 days next week and get to a good place.
Great.
So seniors, breathe easy.
So when do we get to do fun
Not
stuff?
going to do anything extra while you're gone. Sam and Aiden, bring something to do on Monday.
Can we do like the hyperbolic trig functions or whatever they're called?
We can do something like whatever you want. Yep, whatever you want.
I wanna
Bring a
do
pie
those.
for Stevie.
Sounds
Yeah,
good.
we can just have a party with it.
Yeah, and none of the other people are invited. That's right.